Now let us look at some of the solved examples from your textbook. The first question is, show that each angle of a rectangle is a right angle. So first, let us recall what a rectangle is. Yesterday we learned that a rectangle is a parallelogram with one of its angle equal to 90 degrees. So here in the figure we have a rectangle ABCD, and with one of its angle A, say angle A equal to 90 degrees, or it is a right angle. Here we have to prove that all the remaining angles B, C and D are also equal to 90 degrees. To do that, as we recalled just now, a rectangle is a parallelogram. So first let us write down given ABCD is a rectangle. Right? ABCD is a rectangle. Therefore, by definition, it is a parallelogram. ABCD is also a parallelogram, where angle A is equal to 90 degrees. So since it is a parallelogram, we can apply the theorems of the parallelogram to the rectangle. Yesterday we learned a bunch of theorems in which we are going to use the theorems based on the angles of a parallelogram. We saw that the theorem said opposite angles of a parallelogram are equal. So first, to prove angle B equals angle C equals angle D equals 90 degrees. To prove, then proof. Angle A is equal to angle C is equal to 90 degrees because they are opposite angles of parallelogram. They are equal to one another. Similarly, name this as result 1. Similarly, angle B equals angle D. Same reasoning, and name this as equation 2, because angle B and angle D are also opposite angles of a parallelogram or a rectangle. You can call it whatever, and they will be equal to one another. We know that angle A plus angle B plus angle C plus angle D is equal to 360 degrees. This is from the angle sum property of quadrilaterals. So this implies, we know angle A is 90 degrees plus angle B as it is plus angle C is 90 degrees plus angle B, because angle B is equal to angle D. So I am replacing D with angle B, which is equal to 360 degrees from equations 1 and 2. Always remember to write the reasons in the bracket. So this implies 90 plus 90, 180 degrees plus angle B, to angle B is equal to 360 degrees. So this implies 2 angle B is equal to 180 degrees. 360 minus 180, you will get 180 degrees. So 2 ones are 2 nines are 0. So this implies angle B is equal to 90 degrees. This is result 3. From 1, 2 and 3, since angle B is 90 degrees, we know that B is equal to D, so angle D is also equal to 90 degrees. So from results 1, 2 and 3, angle A equals angle B equals angle C equals angle D is equal to 90 degrees. This is the proof. Hence, proved. So we proved that all the angles of a rectangle are right angles using two theorems. That is, opposite angles of a parallelogram are equal, and the second theorem was angle sum property of the quadrilaterals. In the second question, we need to prove that diagonals of a rhombus are perpendicular to each other. We know that rhombus is also a type of parallelogram in which all the sides are equal. So, given PQRS is a rhombus with all sides equal, and it has the diagonals, namely PR. This is the first diagonal PR and the second diagonal SQ. We know that in a rhombus all the sides are equal, so PQ is equal to QR is equal to RS is equal to SP. And we have to show that, name this point as O, we have to show that the diagonals PR and SQ are perpendicular to each other. That is what we have to prove. So given PQRS is a rhombus, this implies PQRS is a parallelogram by definition. Definition of a rhombus, PQRS is a parallelogram too. So also we know that PQ is equal to QR is equal to RS is equal to SP, because it is the property of the rhombus to have all sides not only parallel but equal to one another. So since we are talking about diagonals, let us make use of the theorem of the diagonals to get to our proofs. So here to prove PQ is perpendicular, PR is perpendicular to SQ. That is what we need to prove. PR is perpendicular to SQ. Proof. SO is equal to OQ and PO is equal to OR, because diagonals of parallelogram bisect each other. They make equal parts out of each other. So SO is equal to OQ and PO is equal to OR. Name this as result 1. Now in triangle POS and triangle SOR, OP is equal to OS, because they are the diagonals, they bisect each other. OP is equal to OR, OS is equal to OS because it is common. This is from equation 1, because diagonals bisect each other. And lastly we have PS is equal to SR, because they are sides of a rhombus. So it is given. So this implies triangle POS is congruent to triangle SOR by side SSS rule. So this implies angle POS is equal to angle SOR by CPCT. Also we know that angle POS plus angle SOR is equal to 180 degrees, because they are a linear pair. So since they are a linear pair, since they are equal and they are a linear pair, this implies angle POS is equal to 180 degrees. This is equation 2. So this is from equation 2. POS is equal to SOR. So I am replacing SOR by POS. POS plus POS will get 2 angle POS. So 1s are 90s are. So this implies angle POS is equal to 90 degree, which is equal to angle SOR. So this angle POS and angle SOR are the angles made at the intersection of the point of intersection of the diagonals, and which is equal to 90 degrees. When they are equal to, when the angle is equal to 90 degrees between any two lines or line segments, then they are perpendicular to each other. So this implies PR is perpendicular to SQ. Hence, proved. In the third question, ABC is an isosceles triangle in which AB is equal to AC. AD bisects the exterior angle PAC. So PAC is an exterior angle which AD bisects. And CD is parallel to AB. Our job is to prove that angle DAC, that is this angle DAC is equal to angle BCA, this angle DAC is equal to BCA. We have to prove that, and also we need to show that ABCD is a parallelogram. So first let us prove that the angles are equal. Writing down, given triangle ABC with AB equals AC. Angle PAC is exterior and AD is the bisector. AD or DA. AD is the bisector. So this implies angle PAD is equal to angle DAC. So this has been given to us. They have told us that and CD is parallel to AB. This all information has also been given. So now to prove first angle DAC is equal to angle BCA. We know that AB is equal to AC in triangle ABC. So this implies angle ABC is equal to angle BCA. This is first equation, because angles opposite to the equal sides in an isosceles triangle are equal. So it is property of isosceles triangle. Property of isosceles triangle. So now also angle PAC is equal to angle ABC plus angle BCA. This is result 2. Why is angle PAC equal to ABC plus ACA? Because PAC is the exterior angle to the triangle, and from the exterior angle theorem we know that exterior angle is always equal to sum of interior opposite angles. So name this as equation 2, exterior angle. So now we have two equations. We also know that angle PAC is equal to angle PAD plus angle DAC. This is equation 3. It has been given. AD has bisected the angle, so PAC is equal to PAD plus DAC. Equation 3, because it has been given. So now from 2 and 3 equate equations 2 and 3. Since things are equal to one another, they are equal. Since things are equal to same kind of things, they are equal to one another. That is the axiom 1. So angle ABC plus angle BCA is equal to angle PAD plus angle DAC. But from what has been given, PAD is equal to DAC, and from equation 1 we can rewriting what we have. 2 times angle BCA is equal to 2 times angle DAC. Because PAD is equal to DAC, so replace PAD with DAC, adding them 2 times DAC. Similar thing on the left hand side. So write it down from 1 and given what has been told and given. So this implies 2 cancels each other. We get angle BCA is equal to angle DAC. So we had to prove angle DAC is equal to angle BCA. We proved that. Hence, proved. Name this as equation 4. So, from equation 4, we get that angle BCA is equal to angle DAC, which form a pair of alternate interior angles. So, this implies AD is parallel to BC. AD is parallel to BC from equation 4. From 4. Alternate angles. So, since AD is parallel to BC and CD is parallel to AB, that has been given to us. Since the opposite sides are parallel to one another, ABCD forms a parallelogram. This implies ABCD is a parallelogram. Hence, proved. This is the solution for the question. In the fourth example, 2 parallel lines L and M are intersected by a transversal P. So in the figure you can see there are 2 parallel lines L and M. They are intersected by a transversal P. Show that the quadrilateral formed by the bisectors of interior angles. So these are the interior angles and they have been bisected by these bisectors, and here you can see there is a quadrilateral. We have to show that this quadrilateral is a rectangle. So to do that, first we need to prove that the sides of this rectangle are parallel to one another and also that one of its angle is equal to 90 degrees. So first, given L is parallel to M, this implies, you can see that there are points on the lines. This implies QR is parallel to PS. Similarly, P is the transversal. P is the transversal. So proof angle QAC. Angle QAC is equal to angle ACS. Angle ACS. Angle QAC is equal to angle ACS because they are alternate angles. So this is the first question. So now half of angle QAC is equal to half of angle ACS. If 2 is equal to 2, then half of that 1 is equal to 1. So half of angle QAC is equal to half of angle ACS. These are the halves because AB and CD are bisectors of those interior angles because they have been, no reason is required here. So this implies half of QAC is angle BAC. Angle BAC is equal to angle ACD. Angle ACD. So this is our second result. Now you can see that AC is a transversal with AB and CD as lines. So this implies where this angle BAC and this angle ACD are pair of alternate interior angles. So since alternate angles are equal, the lines are parallel. The lines are parallel to one another. So this implies AB is parallel to CD. Since the angles are equal, alternate angles are equal, the lines are parallel. So AB is parallel to CD. So this implies ABCD is a parallelogram. But our job doesn't end here. We also need to prove that AB is parallel to CD. Similarly, AD is parallel to BC. You can prove these using the same arguments. So ABCD is a parallelogram. But in a rectangle, always one of the angles is right angles. So now consider angle QAC plus angle QAC plus angle RAD, which is equal to 180 degrees, because they are a linear pair. If you look at the figure, you will know that both these angles make a linear pair. So this implies half of angle QAC plus half of angle RAD is equal to half into 180 degrees. Multiply the whole equation by half. So half of QAC, as we saw before, half of QAC is nothing but angle BAC plus half of angle RAC. This is, sorry, make a correction. This is not RAD, this is RAC. Half of angle RAC is nothing but angle BCAD. Angle CAD, and half of 180 degrees is 90 degrees. So angle BAC plus angle CAD. Angle BAC plus angle CAD is equal to 90 degrees. So this implies angle BAD is equal to 90 degrees. So we know that ABCD is a parallelogram, and we found that one of its angles is equal to 90 degrees. So therefore ABCD, this is result 2, this is result 3, and this is result 4. So therefore ABCD is a rectangle. From equations 3 and 4. Hence proved. So now take down your homework. First question is, show that angle bisectors of a parallelogram form a rectangle. This is the first question. You have to show that the angle bisector, the interior angle bisectors of a parallelogram form a rectangle at its center. And similarly, in the second question is from exercise 7.1, that is the first main. They have given the angles of quadrilaterals in some ratio. You have to determine each of their values. Use angle sum property to do that. So in the next class, we'll begin solving the questions from exercise 7.1. If you are interested, then you can solve the examples 5 and 6 on your own in your homework book. And that's all for today. Thank you.